Hello, my name is Abhisoma, and I'm Dhruv Malajkar, and we are part of Data Dragons.
That is my dream. I live what a dream. It's what you make it.
We are currently at the corner of Belmont, Franklin, and Monument Avenue. This was rated one of Richmond's worst planned intersections, according to all of these comments. Now, what makes this intersection so bad? Let's take a look further.
One of the main issues with this intersection is the two fast-moving lanes right here of Monument Avenue. This section right here, which causes cars to pull up from this road onto here and just wait here. And if they ever wanted to go to here or here, they would have to look across multiple lanes of traffic. And since this is not a proper roundabout, there's not a good way to enter or exit here. Secondly, right here, there is a blind spot for drivers coming in to turn here, which causes the pedestrians walking through here to have a chance of being hit by a high-speeding car coming in through here.
Richmond's first city plan was designed in 1946 by Harlan Bartholomew, a prominent cities planner at the time. Richmond city planning has come a long way since colonial times. However, there's still much farther to go to get it up to modern standards. You may be wondering why we chose roundabouts for our design. It's simple, really. First of all, they're safer. There's less of a chance of T-boning because cars enter at an angle. There's also less distance for pedestrians to cross the street. Secondly, they're faster and more efficient. Since there are no traffic lights, there's less idle time. Then third of all, they take less maintenance. Since there are no traffic lights, there's no electricity required to maintain them.
We set out to rethink traffic engineering by blending cutting-edge data, cloud-powered simulation, and AI-driven optimization to reshape how cities move. At the core of our platform is advanced, multi-agent simulation technology powered by hyperparameter optimization that lets us generate and test new road designs in minutes rather than days. What once required entire teams of engineers, months of designing and modeling, we were able to compress into a seamless and automated workflow for our team. We leverage precise geospatial data from the OSMX and OpenStreetMap to model the Richmond's street networks with stunning accuracy down to the individual intersections. But data alone is not enough. It's about how we use it. Our secret weapon? A turbocharged roundabout design built not only to manage traffic, but to completely reimagine it. Using hundreds of design variations and a dynamic range of real-world parameters, our system identifies the most effective solution and tests it in a virtual environment.
Our solution to the problem is an application that can determine the best roundabout design for a specific area. Using given parameters such as road volume, number of input and exit lanes, radius for roundabout, and vehicle speed, the application will run simulations in a virtual machine to optimize and determine the optimal turbo roundabout design to implement rather than an intersection. In the future, we have plans to utilize Google Maps API to lower the number of manually inputted variables and parameters, so the land available for the roundabout will be the only considered factor. We also plan on implementing ArcGIS to fill in the rest of the parameters, such as the vehicle speed and the road volume.
And the results speak for themselves. Dynamic simulations showed smoother traffic flows, dramatically reduced delays, and far fewer potential collision points. Quantitatively, we saw significant drops in average travel times and measurable improvements in intersection safety metrics. This isn't just a theory, it's a scalable, data-driven approach to modernize traffic design, a tool for cities, engineers, and planners to visualize, optimize, and deploy smarter infrastructure faster than ever before. And at the heart of all of it is a vision, a future where urban mobility isn't just efficient, it's intelligent.